extra day in there just in case, so we can get our feet wet and get this figured out, and then go ahead and do it ourselves. This house was originally built in 1850, and it was part of the Pennsylvania Coal Company's property. And what they did was they sold the property to a guy named John Hasbrook. So it was owned by the Hasbrook family. They added on this second part of the building in 1870. So that's the newer section of the building. And this was used at various points in time as a barber shop, as a general store, as lots of different functions. It was basically used as a commercial building for many years. So the building has got some historical significance in the town, and the town was going to charge my father-in-law $20,000 to tear the building down. He asked me to take a look at it, and I said, the building has great bones. There's no reason to tear this building down. So that's... the whole building will be LED. It'll all be run by solar panels. It'll be completely off the grid. There'll be no combustible appliances in the building whatsoever. We actually had them disconnect the natural gas connection. That took me 15 minutes to get the Central Hudson to understand that I wanted them to disconnect us. We were not going to need it. They didn't understand how we could get away with that. But anyway. My father-in-law bought it from the Grimes family and made it into apartments. One of the tenants in the apartment was outside on a patio out here on a deck. He was barbecuing on a charcoal grill. It started to rain, so he pushed the grill against the building, which started the whole fire, which is why the whole top got burned off this house. All of these rafters are all charcoal because they all got burnt, but the roof withstood the fire. We tore off the old roof, but before we did that, we sistered in these 2x12s, and we actually had to jack up all of these rafters, sets of rafters, two at a time, both directions, sister in the 2x12s, and then lower them back down so that we would wind up with a level sheathing on the roof structure. Then we tore off the old sheathing, which was burnt pine, and we put new sheathing in, and then we did an insulation detail on the outside of that of polyiso, then another layer of plywood, ice and water shield, and then we did the shingles. So it's already an insulated roof on the outside. We're going to also insulate in between the rafters, but this eliminates the thermal bridging of the rafters so that we won't have any heat loss through the roof structure. And then we basically rebuilt all of this because it was just in such bad shape. But all of the original timbers are still existing. All these hand-hewn beams, as you can see, are all still here. We tried to maintain as much of the original structural stuff as we could. We moved up all of the collar ties on that side to give us some additional height. The plan is to do cathedral ceiling in these rooms when we're done with wainscoting on the underside. So insulate it and then wainscoting. How close do you want to be to the end? Like 3 inches out?
Yeah, anywhere in there.
This edge? This out? Inside.
Right here.
Okay.
And maybe one right up the middle. Okay, same thing on the other. And then you'll bend it to get the other corner in.
Oh, okay. So like bend it that way.
Yeah. Like in here. So push that one in really good, and then force it to bend. And then other. Yep. So, you want me to do it? See how
Oh,
bend
I
it?
see. Okay, now. That's just to get the fit.
Yeah.
Basically, when you're doing a deep energy retrofit, you're insulating the outside of the building up to all the way across the framing, so that you're eliminating thermal bridging. People don't realize that cold can transfer through wood just like it can through metal. There's a convection value, and that the way that we do a deep energy retrofit, we do an insulation on the inside of the building against the sheathing between the studs, and then another piece goes across the face of it, so that the studs are covered on both the inside and the outside, because this 2-inch is going to go on the outside of this entire building, so that there'll be an R value on the inside and the outside. No air can get in between. That's why we're going to have a heat recovery ventilation system. We're actually going to purposely make this building too tight for natural air changes per hour. We're going to create a circumstance where all of the energy that this building is going to have created by the solar panels we're going to have on it are going to run the mini split air source heat pumps, and that heat and cooling will stay inside the building, but then we have to introduce fresh air. And the nice thing about the ThermalBucks is they're designed to go right up. This insulation material is going to go right up against the ThermalBuck, and it's perfectly flush with it. So then we just put our fairing strips in our siding and we're good to go.
So Bill, now that you've installed a little bit of ThermalBuck, what do you think of it?
I think it's awesome. I think it's going to be great. Yeah, you wouldn't be able to seal woodbuck like that.
No.
It's nice. I like the fact that it bends a little bit to get that top piece in. So it's a nice tight fit. I'm impressed. I think this will be great. I'm very excited.